In science, we often deal with extremely large numbers and extremely small numbers. And so we make use of scientific notation. In scientific notation, there are two parts to the number. There's a decimal part, and then it's times the exponential part, which is 10 raised to a power. This is a way of factoring out tens to make the number more reasonable. If you have a number with 15 zeros in front of it, you can't actually put it into your calculator to do a calculation. So that's an issue. And I don't know about you, but I feel stupid when I have to get my finger out and count the zeros because I can't just tell how many there are. So scientific notation avoids all those annoying zeros. And all it is factoring out powers of 10. They do teach this in elementary school, but you haven't used it, so you probably let it just slide out one night when you weren't paying attention. So the decimal part and the exponential part. A positive exponent just means the number 1 multiplied by 10, that many times. So if we have 10 to the 0 power, that is 1 multiplied by 10, 0 times. We won't run into that one very often. 10 to the 1 is 1 multiplied by 10 once. 10 to the 3rd power is 1 multiplied by 10 3 times. Another way to think of it is the exponent tells us how many zeros are after the 1. So 10 to the 4 would be a 1 with 4 zeros after it. When the exponent is negative, we're dividing by 10. It's making the number smaller. So 10 to the minus 1 is 1 divided by 10. 10 to the minus 3 is 1 divided by 3 tens. 10 times 10 times 10, or 1 1,000th. So it's awesome to understand what scientific notation does. What you really need, though, is to be able to convert between scientific notation and decimal notation. So if we have a number in decimal notation, like this one, 5,983, and we want to put that in scientific notation, what we do is we move the decimal point. Now, this number doesn't have a written decimal point, does it? But we understand that if we're going to put a decimal point, it would be after that 3. We need to move the decimal point so that it's after the first non-zero digit. It needs to be after the 5. This decimal part of the number is always greater than 0 and less than 10. Well, actually, it's 1 or greater and less than 10. We're never going to see 59.83 up there. Always 5.9. Okay? So we put the decimal there after the first non-zero digit, and then we count. How many places did we move it? Well, 1, 2, 3, right? That's the exponent. So the exponent is 3. The problem that students have is, well, is that a negative exponent or a positive exponent? Right? And your book will talk about moving the decimal point to the left is one and to the right is the other. I have a hard time remembering that. So this is how I remember it. If this was a large number, the exponent is positive because I have positive feelings about large paychecks. When I get a big check, I feel positive. When they give me a little puny one, I feel negative, right? This is a small number, 0.00034. This has a negative exponent. So just ask yourself, oh, is it a big number? How does Mrs. K feel about big paychecks? She feels positive. It must be a positive exponent. Okay? Works every time. So in this number, 0.00034, putting that in scientific notation, we're going to move the decimal point to after the first non-zero digit. So you start at the left and you just go across till you come to the first digit that's not 0. So that's the 3. So we're going to put 3 and a decimal point and write down the rest of the number. We count how many places we moved it. It's from the decimal point, not from the end of the number. I don't know why people get started on that. What I've noticed is somebody will have a crazy idea, and then they tell their friends, and it spreads like wildfire. And it's like, what the heck? I've never seen students do this thing before. Just one person started it. If you're not sure what you're doing, don't instruct other people, okay? Ask me. So we're moving it 4 places after the 0. This is a small number. Mrs. K has negative feelings about small paychecks, so it's a negative exponent. Okay? You can also do this on your calculator for numbers within a certain range. And how you do that, it depends on which calculator you have. So let's just try this one. The total U.S. national debt in 2013 was approximately, wow, big number, right? In everyday life, we often use commas to separate the digits so that we don't have to get our finger out and count. In chemistry, we almost never use commas. So if you see what looks like a comma in my handwriting, it's a sloppy decimal point. I wanted to make it large enough that you could see it. I don't use commas to separate. If I need commas, I'm going to put it in scientific notation. So if we want to put this into scientific notation, where are we going to put the decimal point? After the 1. First non-zero digit happens to be the first digit, so 1 point, and then I'm going to copy down the rest of these non-zero digits. We're going to learn what to do about those zeros later. For now, we can ignore them. So 1.6342 times 10 to the something? 13. So what we can do here, this actually is a period, not a decimal point over here. But here, I'm going to count by 3s instead. What the heck am I doing? Having an argument with my iPad. 3, 6, 9, 12, and one more. I moved it 13 places. So the exponent is 13. To determine the sign, I ask myself, big number, small number? It's a big number. I'd feel really positive about that. So there's the number in scientific notation. Any questions? Let's try another one. So here, again, we have to put the decimal point after the first non-zero digit. So the first non-zero digit is a 3. So we've got 3 and a decimal point, and then there's an 8 after that. The decimal point started out here. I'm going to count how many places it moved. So 1, 2, 3, 4, moved 5 places. The exponent is 5. So times 10 to the 5. Positive or negative? Negative. Negative. It's a small number. Okay?